Welcome to the talk on Maven Renewed. I am John Engelke, Data System Software Specialist at Jet Propulsion Laboratory. And we're using Maven for some of our software. We use it, we have a number of different languages that we use for different products. We have builds that are, multifaceted. They integrate different modules that are programmed in different languages. And we're starting to migrate more to a Maven model. And during the whole process of that, I discovered that Maven has really evolved. And so that's really what this talk is about, the evolution of Maven so that it can be used more readily with modern build systems. So Raytheon's one of our partners. I actually work at JPL through Raytheon, so we give them credit for helping. And excuse me a moment. Okay. Did that do anything? Yeah, it broke it. That's what it did. Yeah, let's try that. All right, fine. We'll just do it this way. Okay, so the premise of this talk is Maven Renewed, which begs the question, why renew something that works? Right? Maven works. It's been pretty steady state, pretty reliable for the past 15 years of its life. People are using it all the time, and it's being used in all different industries, largely for Java, but I also have used it to publish Python projects, and we did some testing, used it for just integration testing and maybe some unit testing. There are some Maven's so extensible you can use some different plugins to actually do testing in different languages or to do deployments in different languages. And there are some competitors. I mean, there's NPM, and there's some other tooling for C++, C#. But I don't think anything really measures up to Maven in terms of its longevity and its utility. But why renew something that works? Well, let's take a look at what's going on with Maven, and why renew it? The simple answer is make it work better, make it more flexible. So this talk is really about a practical solution to make Maven faster, much faster than it is. And although Maven may not seem slow if you're using it for a very long compile, and you're using it to do releases and tagging and all sorts of other things, you will notice that you're going to have multiple builds, and things are going to sort of drag on sometimes when you don't want them to. And in today's fast-moving world, of course, everybody wants to have their software out quickly. They want QA to test it. They want feedback immediately. If you're a developer, you want to know if your software is working or not right away. And managers want to know that too. So this is really a practical solution to make Maven faster. It can be used to modernize the legacy installations. So if you're using the standard way of using Maven, which has been around for 10 plus years, 15 years, the life of Maven, this is going to modernize it. What I'm proposing is a relatively quick and easy implementation, which could be done almost entirely in a parent POM. It could be done simply by removing some build plugins. It could be done simply by changing some things in the POMs themselves, simple properties. And so it's relatively quick and easy. Maybe not, if you're used to the Maven paradigm, maybe not as easy as it seems. And it will definitely bring Maven into the 2020s, well, at least into the 2010s, I think. And it offers runway transparency. What do I mean by runway transparency? I mean, it's clear what software is meant for and what it is. So with this solution, SREs can say this issue came from this exact commit hash. They can tie it exactly back to the exact commit hash in the source control system. You can say this is from a developer's desktop build. Why is this out here in production? Because we all know that some developers have had to do that before. They can say, this is build X, which passed by QA on date Y. Hi, QA, why did this pass with this nasty problem? And so this is a real big help for the people who are out on the front end of finding issues with software that's running on a production service. And it's actually relatively simple. So another benefit is that continuous integration and continuous deployment systems are recognized in release tags. In release tags. Now, I'm sure people are doing this already, and I've seen it done before, but this is making Maven do it, and it's making Maven do it without its legacy way of doing things. And a lot of installations people are working on and supporting right now with Maven are actually older installations that are just sort of being maintained, right? And so nobody wants to make a giant change to a working system, right? But this change makes it worth it. That's the point. So bottom line is that every release stage actually can be identified. When your software goes to the CI/CD server, you're going to see a build number. You're going to know the commit hash from the source control system. And you're going to, of course, have a version from the developers. So everybody touches this, and we know what they touched exactly. I think at this point, I know it was marked as welcome. Thank you for joining. I think there will be. It'll be tight. You might have to stretch your legs, not be able to stretch your legs out, but I think at this point I wanted to have a brief review of CI/CD concepts and what I think is actually how this is going to benefit the whole process. What I had just done right now is I've done a quick overview of what the talk's about. Now I'm going to walk through some of these concepts, talk a little bit more about Maven, the assumption being that maybe I wanted to make sure everybody was on the same page. So, what I want to talk about is what continuous integration, continuous delivery really means, why decoupling is important, why failing fast and failing often is really important, and why people should get told if they fail. If you fail, you get a chance to fix what's wrong. And so failure is a learning experience. And traceability is another critical component of the solution here. So point of continuous integration, continuous delivery. Well, continuous integration definitely validates software works when it's combined together. As we know, developers work in silos, and software just builds and works, right? So when you put it onto a Jenkins server or some other CI server, you're basically testing whether the component which was developed separately is going to work with all the other components that were developed separately, or if the component that worked on the developer's machine because the developer had a bunch of interesting libraries installed actually still works on another machine. So that's an important aspect of CI. The code freeze aspect's important. When it gets committed and bundled and stuffed into a jar or stuffed into some other kind of package, your code's locked down. The build's locked down. As important as everything else is automating things whenever possible. So in a continuous delivery environment, you want to make sure the build works. And then you want to also make sure that you can run some integration tests against your build and that it's pushing through all the way to production because that's the idea. And it's working. Of course, it's difficult to have software that is testable only by automation, but that's a goal, to have it testable enough by automation so that a continuous delivery process can move along and push something out to production. And of course, every build is a potential release, right? So in today's world, the paradigm Maven has been working on for the past 15 years has sort of been a paradigm of snapshots and builds and tests and then releases, pushing things along the runway maybe a little more slowly. But in today's world, with continuous delivery, every build is a potential release, and of course you have the eternal beta strategy. And some companies, we know some companies that do that, right? Google is a company that has the eternal beta strategy in mind. I'm pretty sure Facebook does that. I think on Tuesday nights they do their developer powwows and push their software out Wednesday mornings. And so that that's fraught with some risk, but if your CI/CD system is good enough, it catches any problems before things actually leave the system. Decoupling. Why is decoupling important? Components work independently, software and release management. So when things rely on other things to run, sometimes if that other thing doesn't run, then the thing you really need to run won't run. So we want to decouple as much as possible. Given system is not required for process completion. I can read this off. But really what we mean by that is that we want to be able to jump into the middle of a process and restart if something breaks. Keep pushing down the runway. CI/CD. Make sure that there aren't too many things that are tightly coupled together in your system chain, so that, for instance, your Travis CI system won't run if another system doesn't do a build before it, or it's relying only on some kind of web service or something. Try to stop that. So minimize interdependency, coordination, and information flow. Fail fast, fail often. I find that's very important. And you want to notify people as soon as something fails so they can get on with fixing it, or prevent something worse from happening. Make sure that when you fail, you actually stop the runway from pushing, or keeping pushing on down the runway. Why you want to fail is because when you iterate over problems, you fix them faster. And it isolates the cause, right? If you fail in a particular build process or area of the build, you're going to know you're failing because the CI system didn't work. You're going to know you're failing because the deployment didn't work, or this particular stage in a runway, something didn't get pushed down. And so in the world right now, we want a constant feedback from the CI/CD systems. Traceability. I think that's what this is really about. So I want to be able to say what I said earlier, which is if I'm troubleshooting a problem in production, I can go look at a list of files that were released, and I can say, oh, it came from this commit. And I can go all the way back to that commit, and I can see who did the commit, and boom, I just send it back to the developer who did it. I don't have to go start looking at version numbers and cross-correlating this or that. And so at this point in the development process, there was a failure. That's what I really mean about traceability. The build system is going to touch the software, and when the software is released, it will add the build number to it. How is traceability implemented in Maven? Well, in a whole CI/CD system set up based on Maven, there's counters, hashes, coordinates. What is a counter in this case? Well, we have an incrementation that happens during builds. Every subsequent build is one more than the last build, so there's a counter right there. Source control has hashes which are published. And Maven itself has coordinates for everything, GAV, group, artifact, and version. So this deals mainly with modifying the version component of Maven so that we can get these other mechanisms in there. All right. So release management is important. Maven's maybe one component of an entire release management system. It's a build system. You want to have a controlled release management stack so you understand what's going on. And the bottom line is you want a repeatable process so that everybody, the developers, everybody throughout the whole process has a shared lexicon and they can understand what's going on. This thing built, this thing failed. We know that this came from this particular commit hash. We know that the build system failed on build number X or build number Y. Predictable outcomes. Release management needs to provide predictable outcomes. Software gets committed to source control, software gets built, software gets published, software walks down the runway, software goes to production. And we want to be able to know what our artifacts are. We want to be able to pick up our artifacts and be able to go to maybe a location where we store them and see that, hey, this is the artifact that was built on this day. There's a lot of value-added benefits in terms of helping us speed things along in terms of identifying. Sure, exactly. And so I have, I put a little drawing up here on the board, which sort of talks about where Maven is located. Again, this is sort of a review. I'm sure many people know this, but Maven sits between the developer and the CI/CD system. Also useful for publishing down to the Artifactory repositories, Nexus, Artifactory, etc. Packaging. It sits in the middle of packaging. It packages the jars up and packages things into components that can be published.
Question.
Sure.
Pretty new to this world, so a lot of it's unknown, but what is an artifact?
Yes, okay. So an artifact is I would say, a bundled component that is put together and published out of a build system. So for instance, if you're in Java, if you're compiling a bunch of classes, if you're compiling a bunch of Java files, they compile into classes, and they're bundled into a jar, or a Java archive. And then that can be published to a separate library, or a separate server, which serves as sort of a library to hold the artifact. So, so the jar would be the artifact, and you'd want to name it appropriately. So it would sort of be like a Dewey Decimal number, and you can go look it up again. That's an analogy. It's not exactly what we're doing, but yeah, that's what an artifact is. And that could be anything. It could be a tarball. I mean, it could be a Docker image. You know, there's many kinds of different artifacts that can be stored in modern repositories. Sure. Okay, so I'm going to talk a little bit about Maven itself, since of course this is a subject. Okay, Maven is based on POMs, a project object model. Yeah, exactly, yeah. And it's an XML file, right? I'm going to go into that in a moment, but it's based on a standard directory layout, build lifecycle. It's got dependency management for both itself, right, build plugins and project plugins, and it's extensible, which means it's not static. You can write a new plugin and make it do things, or you can modify the actual POM, the XML in there, and change the XML in such a way to make it do something a little bit different as you would like, depending upon how the plugins are written. It's XML. I said that already. And so the XML is really a descriptor of what's going on, and then the Maven application executes against the XML file, and based on what's in there, it performs a series of operations. Okay, well, I mentioned Maven's 15 years old. It's very widely used. There are 2.3 million dependencies published and used routinely in Maven Central. So there's a repository called Maven Central, which is where most Maven dependencies are stored. If you're doing anything, a lot of times you'll be grabbing a dependency of something that somebody wrote and bundled up and packaged and published to this internet archive called the Central Repository, and it will need to use other dependencies that it used in building it. So when you run a Maven build, you're pulling dependencies into your local system, but those dependencies specify other dependencies that they need to run too. And so it's really a system that pulls in a number of different compiled pieces of software to allow the final build to go forward and to run. Okay, this is a snippet of a POM. And the reason why this is important is because it specifies the GAV coordinates, group, artifact, and version. Okay, and what we're going to be focusing on today here is a version. This is the basic components of a POM, which are actually necessary to label or publish something if you compile it. This is what actually gives the software its coordinates when you actually do the compile and the package. It's a standardized system. It's based on a standard directory layout. And so Maven goes and looks for things in certain places. You could customize it, but you wouldn't want to. And so the standard layout has a place for the source code, a place for resources, things like config files or static libraries that are used by the source code. I won't go into filters, but it's a directory that's used to filter objects you might want to bring in. In my experience, it hasn't been used very much. A web app folder where you're going to publish your WAR files or maybe have your HTML. It's got a whole directory hierarchy dedicated to testing, so unit tests can be built in here. This whole directory structure is integrated in common IDEs like Eclipse, IntelliJ IDEA, NetBeans. And so with plugins in those, because Maven's so ubiquitous, it just automatically picks up your source code when you load a Maven project in. Okay, now this is interesting. Maven's a stepwise product, and it's based on phases, life cycle phases. So the life cycle is really a series of steps that are executed in order to get from the beginning of a non-compiled product to a completely compiled product. And as the steps walk through, you can tell it to run to a particular life cycle phase, or you can tell it to run all the way through the entire life cycle phase. The life cycle phases include things like cleaning up the old compilation artifacts, which are sitting in a directory. Include things like deploying to a server or installing that artifact locally. What I don't think this mentions is that Maven actually has a local repository. There's a remote repository, right? That's something like Nexus or even Maven Central. And then you can publish things locally inside your organization too. You can run tests. You can only compile your product, so you skip all the other phases. Maven is, and you have the option of actually tying different operations. If you want a particular thing to happen at a certain point during the building of your product, you can modify, most plugins allow you to modify the actual configuration in the POM files so that you can tie it to a particular phase. One of those is a site plugin. I think you can tie certain aspects of it to the packaging phase, and it's actually very flexible. This is what dependency management looks like. It's what I mentioned a few minutes ago. I think I mentioned that if you bring one thing in, sometimes it can pick up different transitive dependencies and bring them in. There's a resolution procedure for dependencies. Usually, I think it prioritizes the latest dependency. That's not always the case, though, so you have to be careful what you're bringing in, and you can specify the different dependencies that you want. What's interesting about this is that in certain scenarios, you can almost, I don't know if you guys have ever heard of the deadly diamond of death. So in certain, so in certain scenarios, you can have a dependency version of that. So you can have something that's getting picked up, and maybe it's picked up erratically or sporadically, and it's causing a problem with some other piece of software that needs to have a similar dependency, and it's using that, but it can't get the previous dependency. So that takes a little troubleshooting to get past. So of course, Maven's extensible. The dependency mechanism, like I said, applies to projects and Maven itself with plugins. And these are some examples. You got a packaging through the assembly plugin. You can change how things are packaged. You can package them in tarballs or gzip tarballs. You can run scripting in the middle of your build to maybe move some things around or modify a config file a particular way based on how you set something at the command line. So for instance, there's a Groovy Maven plugin. And the release plugin is what has traditionally been used for software tagging and pushing. All right, so now we're going to get to the core of what I'm proposing here, renewing Maven so that it publishes things a little bit differently. Go back for a second. Okay, so releases. Hello. That sounded nice. Can you hear me now? So the release plugin is a de facto mechanism for tagging and publishing artifacts. What I showed you earlier was just the basic POM GAV, group, artifact, and version. Those are the coordinates used to publish everything in the standard mechanism. Release plugin's been around for a long time. It's one of 4 plugins that have evolved. I think another one's a compiler plugin, probably the deploy plugin. And the release plugin actually runs through a series of synchronous steps that execute multiple phases in Maven in order to get to the build product. Okay, so here's the problem with a standard traditional Maven installation. You're walking through a bunch of synchronous steps, which means you're repeat processing. Right, because these steps have to happen over and over again. So what happens when you do a Maven release is there's a number of things. I'll go through it in a moment. But it makes modifications to the POM to change the version. It makes modifications to a file, and then it pushes it to the source control. Performs a tag and pushes that to a source control. And then once it makes that modification, well, it does a build again to make sure that modification worked. Right? And then, you know, in the middle there's a test build. There's a lot of different things going on.
It takes off -snapshot, then has to rebuild.
Yes. Yes, yes. And that's the standard paradigm with the release plugin. And that's why.
Clean first, at least it reuses what hasn't changed by now.
Let's see. If you stop. I'm not sure if it does a clean in the middle between steps. It might. I think it does, actually. Yeah, so it just throws out what's there and does a complete recompile. And so that's the problem, right? Patch version changes result in a complete rebuild, which means get rid of the snapshot. And then it has to push a snapshot version later, right? So that developers can develop against a snapshot. Is this valuable? I don't think so, not anymore. Because I think development and developers have evolved enough so that we really do understand that what's going on when you make a minor change, and that you can be impacting a bigger system. I think we're handling that use case with testing now in release management, right? So if somebody makes a minor change and they push it, if your testing can't catch that, that's when you've got real big problems. Okay. So costly recompiles violate fail fast, right? Yeah. So you might fail at the second or third level. Why, I don't know, but you could. Multiple recompiles over source code changes tie systems together, violating decoupling. So you're relying on picking up changes that you've just submitted, committed, get committed right to get, you've got a big problem. It could fail in the second or third. Anything could happen. What I mentioned before, the semantic versioning requires multiple lookups maybe to reconnect the dots for traceability. So you get out to production, you've got something with the traditional method, and it's versioning it as 1.x.y, right? And now that's what you see there. And do you know exactly what commit that came from, what it was built from? No, you've got to go back and get into Git. You've got to check that, see maybe what changed, find out what the last commit was. There's a little bit of work there. It's nice. It's actually really nice for SREs if they can say, I know exactly what build this came from. And so you have many different operations happening during a Maven release. Consider the case of a 15-minute compile. Okay, now you've got a 45-minute compile. All right. So this is what happens with the standard methodology. The red box is the number of things that are actually happening during a Maven release process. So you've got 2 POM changes, right? So you do a release, you remove the snapshot, and you update the version, increment the version, okay? Or you remove the dash snapshot, and then you publish with that version, okay? And then you increment it again, add a snapshot, clean compile test. It's running 3 times, so you're having 3 executions of the compile phase. Ouch. Commits, right? You've got to commit the POM twice because you changed it twice. So now you're pushing stuff up to your source code system twice. That's not exactly a cheap operation. It could be, but it's not exactly.
It can also trigger other things.
Yes, it can. That's right. And so you've got to be, thank you. You've got to be very careful. I had that situation when I was working on a project at a place recently where we had to actually catch some of the commits and stop the triggers. It was nasty. Well, you're pushing tags too. And Maven executes multiple times. So that's an ouch. Now, the new approach is basically throwing out the release plugin. We're going to change the paradigm. We're not going to use a release plugin. We're not going to use Maven's built-in mechanism for doing releases that has been with it for 15 years. And we're going to boil it down to 1 clean compile test cycle, 1 SCM revision, and 1 Maven execution. Now that saves a lot of time. On a 15-minute compile, you're going to go down from 45 minutes plus to 15 minutes. I mean, that's really valuable. Okay, so the legacy approach is you usually run this command at the top, release prepare, release perform. So when this earlier slide here said there were 2 executions of Maven, what it meant was basically in order to get the release out the door, you have to do a prepare stage, and then you have to do a release perform execution. So you're running it twice with 2 different targets against the plugins. And so that's a problem. I think we've talked about all this, but yes, we want to make it so we can correlate the release output better with the actual inputs. Okay, so CI-friendly Maven. So goodbye release plugin. I'm going to remove it from all the POMs. Just wipe it out. No more release plugin. We're done. And we're introducing a concept of flexible versioning properties, which are bug-free and stable since Maven 3.6.3. Now, they were introduced in 3.5, but 3.5 had some problems with dependency resolution. And the place I last worked at, I worked there for a number of years, there was an idea that it was a very regulated environment. There was an idea that you could actually separate the code into tiny little modules, and so then make fixes in those tiny little modules, and then testing could just approve a tiny little module and say the whole product works. But it doesn't actually work that way. You know, if especially in a regulated environment, maybe you change a tiny little piece, right? So you've got maybe we had 80 modules. So 80 dependencies for a product we were building going out the door. So 1/80th changes, QA or the regulators, they still want to check the whole thing completely over again end to end. They don't care if that tiny little piece changed. Their whole, and especially, I mean, it's a good idea, but when you get to very low level in the product, something that affects everything, like maybe a library that controls JSON processing, for instance, or some kind of monetary calculations. You change something in there, and it can definitely cascade through the whole product. So unit testing only goes so far. Contrast that with some place like Google, which I heard a few years ago, really had just one repository. We had, 80 modules in 80 different repositories.
They call it a mono repository, I think.
Yeah.
Everything has the same Git hash.
Right. So, let's see, would this work there? This might not work so well there. But maybe it would, right? Because you could tell when something broke because it would be that hash and you could see what changed. So 3.6.3 is the way to go. It's actually the latest Maven, and it doesn't have the dependency resolution issues where it would lock up. And it includes three properties that it is allowing to go into the version: revision, SHA-1, and change list. Okay, so you do this, and you're modifying your version property, and now you have to use something called the Maven Flatten plugin, so that when you publish this to an artifact, a jar, that the Flatten plugin makes sure that the snippets of the POM actually have the properties fleshed out inside that snippet of the POM that goes into your jar when it's published. And in order to publish it to source control management in terms of tagging, you have to do a minor change to the SCM plugin to make sure that it picks everything up the way you want. All right, so Here's an example, actually, of the change. So remember, the release plugin's gone at this point. So how we deal with that is we're adding new properties in. But not only are we adding new properties in, but we're defaulting them to certain fixed values. And we're doing it this way so that we can actually see what happens when we do the build, right? So we can see what happens depending on how we set up the build, right? So with these default values, for instance, for the revision 0, right? So a revision of 0, revision is really correlating to a build number in something like Jenkins. But if a developer is running it on their own machine, they don't have a build number, it's always going to be build 0. The SHA-1 hash, if someone, that has to be calculated and that property has to be inserted. If someone doesn't insert that, it's a key that it maybe wasn't built in a build server, but it gives us, more importantly, it gives us a placeholder to actually insert that, right? And the change list defaults to snapshot, so whenever a developer builds, it's build 0 snapshot. So you...
Is the SHA-1 equivalent to the Git hash?
Yes, exactly. But it's not filled out automatically. This is a property, right? So we have to fill that out. We have to calculate the Git hash. And put, now, the good part, the great part, is that these kinds of things are already available in the CI/CD servers, right? So we're good. We can grab the variables from the servers and we can put them there. So if you look at the version number, 1.0.0b revision, in this case it will be 0. SHA-1, okay, it's empty. And then change list is -snapshot. So you're going to end up getting an actual build from this that is reflective of what Maven was doing by default previously, but with a build number added, which is a key, build 0, that it was built on a workstation. I mean, somebody could always fake it and do something, right? But it's unlikely.
Well, it didn't have to get checked in to get that way, and therefore it'd be traceable what they did. Otherwise, the build server wouldn't see what they did.
Well, yes, they could do that, right? That's one mechanism of doing that. But you can also replace these in the command line, so that's the key here. So if they do it in the command line, yeah, you know. But anyway.
Or they could put their artifact in the artifact repository that
Yep.
on their machine.
They,
Okay.
when you get into the realm of guessing how people are hacking things, there's a million ways they can do it. Just rely on people at some point to do the right thing. Now, another really interesting part of this, I don't think this shows the mouse, does it? Oh, it does. Is right here. See, I have the version here. So this is a semantic version. So what was happening before is the release plugin was actually controlling the semantic version, but only partially controlling it, right? So you got major, minor, patch. So it was controlling the patch version. Right now, developers would set major and minor. This kind of changes that, and I think it changes it in a good way, because it actually puts the onus of managing the semantic version on the developers, and they really should be the ones who are doing that. Now, if they came in and changed a POM file, and there was a spelling error, it said Jet Plopulsion Laboratory, and they changed that to an R. I don't think that really counts, as something that should be counted as even a patch version, So we're kind of moving forward here with the whole conceptualization of what it means to be a developer and the responsibilities of managing your software. You're a developer, you make a major change, you make a breaking change that breaks the interface down below it. Okay, change either the major version or the minor version. If you do a minor fix, like change the character that was asked in a bug report, a character in some text, okay, make it a patch version, change. But now it's up to the developer to do that, and they can make that decision. Now we can see that things change because we will know that the hash changed, and we'll know that the build changed, right? And we'll know that it won't have a snapshot. So let me keep going here. So, okay, so we do all this, right? And we've got this whole system set up. this is a second component of it. We have to add the Flatten plugin to our parent POM, or maybe to our main, our project POM. The reason we want to do this is so that when we publish things, right? So previously Maven was taking care of commits and pushing and changing the POM. And if you take a look at the version, if I go back here, the version was actually, didn't have these property placeholders in it. So the Flatten plugin is what takes care of that. Takes care of fleshing it out to complete text, rather than leaving property placeholders in something that mean nothing when they're published inside of a jar. Okay, then you've got the source control management plugin, and you want to be sure you modify your tag so that your tag version reflects properly on what your project version is. Now, I think there's a glitch in here. I don't think project version is what I wanted. I think what I wanted to do is I actually wanted to flesh it out with something more like this right here, so that you would actually put the version. It would pick up those placeholders that are appropriate for that particular build. But that allows you to tag, and your tag, you would run the SCM tagging operation separately now. Rather than relying on the release plugin, you're going to run multiple steps, right? But releasing is really only one major execution of Maven with the compiles and stuff. The tagging is, you can do this in the same command. I guess it could be considered an extra execution, but yes, I would. Yes. Right, right. Okay, so I'm just going to go through putting it together here. So the release implementation. Build versioning is controlled with the Maven property injection, right? So when you execute Maven, you're going to put the -D flag. Property name is equal to something, right? And what I had mentioned earlier, the keys to the development build are these values being in the actual artifact name. And so you set it up in your CI/CD system in Jenkins. So when you execute Maven in Jenkins, you actually put the correct properties in there with the actual values, the actual properties that are provided by the build system to fill it out.
Jenkins is holding those in variables you can just put in the command.
Exactly. Yeah. So that's the key here, right? And it's actually pretty cool because it gets rid of all the overhead of publishing. So again, everything's going through a single phase rather than multiple phases. Yes. Yep. I'd have to think of an example. There is an example where it would fail on the second or third build. I've seen it happen. But yeah, right. There's something happens. But yes, it's exactly the idea. Complete traceability. So you can retrieve the exact build from the CI/CD server, so you can see in your list of builds what build it actually was, where the problem happened, or where something in production came from. And you can tie back the exact source code commit, which is what I've been hammering at this entire, which correlates, tags, everything. And developers control semantic versioning. You're no longer subject to, the actual release process specifying your semantic versioning by just changing an ancillary release file. That doesn't have anything to do with your software, right? Change a POM, that doesn't change your software. So why should a patch version change? Because you can simply not change any source code, and you can run the release plugin 2 or 3 times, and you've got patch version changes. It doesn't make any sense. So I think this mechanism makes a lot more sense. Okay, so this sort of gives you an example of what it would look like if a developer, and I used an open source jar library, Jetty, to show you what it would actually look like. So if your version, if your semantic version was this, and you're building on a development workstation, it fills in the 0 and it adds a snapshot. So you would get this jar right here with this naming convention in your local repo. Or if somebody pushed it up to the the artifact repository, it would look like this. The server would do things a little bit differently, right? So it's going to start including the build number and the SHA number. You can specify it. So if you got build 1170 and your SHA is this, you're going to end up with this jar name. So for the same jar in a release scenario, 9.4.18, build 1170, boom, you know what happened here in this build for this project right here inside your CI/CD server. And you know the exact commit. And this is what would get pushed out to production. So you'd actually be able to look at this in a production environment and say, oh, wow, OK, I know where this came from right here. I know the build that produced this. Why is this having problems? We know the build. Let's go look at the build. And we know the code was at this particular exact stage. OK, so semantic version is more of a concept than it is. So semantic version is embedded in the Maven version, to answer your question. And so the Maven version becomes a longer string instead of just having like major, minor, patch. You got major, minor, patch, plus build number, plus change list, plus SHA, right? And so version, I guess I'm using version for two different things here, but that's why I'm saying semantic version versus version.
Okay, yeah, I think the only reason why I asked, I think I'm struggling a bit. So like if you use this semantic version, you deploy your dependency into Artifact or your Nexus or wherever you're storing your artifacts using that semantic version, and you have another like in-house dependency that I guess depends on that. Like how do you reference? If that makes sense. So like if I deploy some version, some snapshot version for one project, right?
Okay, it makes sense. Yeah. So you're going to refer if you're referring to a particular. Oops, let me go back. Referring to a particular jar, you're going to use the entire version number here when you're doing the dependency specification. So it's going to go look for this. It's capable of actually you're going to know what you need to use, right?
In a highly regulated environment, yeah.
So you can go pick out a particular build and build against that. Hopefully the CI/CD server is publishing Java doc. So if somebody actually needs to upgrade a version, I guess the paradigm now is why would you, if it's feature or functionality in the interface of the product, you would actually go and seek out that product, but maybe not necessarily upgrade it if it didn't need to be upgraded. Make sense? Sort of. What's that?
I think, were you asking about dependencies? If you're writing something that depends on this, then every time this changes, you have to go and change your dependency.
Yes, yeah, that's right. So, but look, because the developers are controlling the semantic version, you're going to be able to pick this build out, right? I'm assuming that it's not going to build. It might build if somebody hits the build button, right, and forces a release. But generally, it's not going to build. I mean, you're not going to need to update it unless the developer is cognizant enough to make changes and then upgrade the semantic version, because nothing really changed unless the version changed, right? So you would be able to go get any one of these builds, and there hopefully would be only one.
For any semver, there should be one complete tag.
Right. Okay. So these are the commands. These commands on a local developer workstation would actually create a snapshot build. It's a pretty concise command right there. Developers also own snapshot deployment. You can deploy a particular snapshot. So I wouldn't I have an error here. I wouldn't change the revision here if I'm deploying a snapshot. I would add the SHA from a developer machine. Release engineers own releases and configure CI/CD servers to tie builds to commit hash. So that command would look something like this. You set change list to nothing. So then you get this with build. We're assuming build 377 came out of the CI/CD server, and the hash is added, right? Because here we're setting the hash. And the build number is being picked up from the CI/CD server. This is what happens if you... I wonder if that got duplicated. It might have. But this is what that looks like. Let's see. OK. So for a minute, I'm going to talk about the pipeline implementation. So the server, CI/CD server tags and pushes the build artifact to a repository. In this case, when you actually publish something, a webhook, or possibly, can be sent to a subsequent process kicked off to keep pushing that down the pipeline. And when you send that webhook over, you can send it the name of the artifact that you just published. And as things flow down the runway, the software is completely traceable. OK, so build times reduced. This is the benefit. Build times reduced. People oftentimes talk about Maven versus Gradle. Well, if you can make Maven this fast, Gradle has a big learning curve, especially those eternal beta guys. They went with Google. They went with Gradle for their Android development. But maybe they didn't need to if Maven was running this fast. And so this makes Maven, where people oftentimes talk about it being slower and less agile, it makes it into something that's a lot faster and a lot more agile and a lot more flexible, and it can be used going forward into the future, and that was the point of this. I have some references here and questions, and we already answered one. But I can try to clarify that more if you're interested, if you want to come up after. But yeah, the coordinates, you would know exactly what you want based on the entire, let's call it the Maven version, rather than just relying on a semantic version, because that's what's going to end up getting published.
Okay.
Yeah. Any other questions? I would have been happy to do a demo during this, but unfortunately, passing that through a review process is not as easy. They want to look at every slide and everything you're doing, and for good reason, right? So, okay, well, thank you very much.